Hello everybody, and welcome to example 2 on page 30 of the workbook. And this is another example of finding areas between curves, but the situation is sort of set up a little bit differently. Okay, so in every area problem that we've done up to this point, our curves were given in a very special form. They looked like y equals g of x and y equals f of x. They were functions of x. And we thought of the area as being the difference between the top curve and the integral of the difference between the top and the bottom curve. Now in our case, we don't have functions given in that form. In other words, we don't have things that look like y equals f of x and g of x. We have x equals g of y. Okay, so if we wanted to use the method that we've used up to this point, we would have to solve those equations for the variable y. And I think we could manage that with the curve over here to the left, but I'm worried about the one to the right. Okay, that would be very difficult to solve for the variable y. Okay, so what we're going to do instead is to change our method around a little bit. Okay, so instead of thinking of a curve on the top and the bottom of our region, we're going to think of a curves being on the left and the right of our region, and draw our rectangles this way. Okay, instead of vertically. Okay, now to measure the area of a rectangle like that, what we need to know is how wide it is, and that means finding the x-coordinate on the left and the right-hand side of it. Okay, conveniently, those two x-coordinates are going to be given by just the two formulas that they gave us. Okay, the only question is, which of these two curves is on which side? Okay, that's the one thing that we have to figure out. Okay, now there are a lot of different ways to do that, to figure out which curve is where. One way is to look at points on the curve. So in particular, what's that point? That's just the origin, and notice that that point 0, 0 lies on one of the two curves. Okay, which of the two is it? Well, we can figure it out by looking at the equation. Which equation is a true statement if you substitute in x equals 0 and y equals 0 at the same time? Okay, if you think about it, this is the only one that's going to work. Okay, so my comment is the following. Since if we plug 0 in there, notice that that's a true statement. We get 0 on both sides. We know that 0, 0 is a point on the curve x equals y cubed minus y, and therefore that curve must be the curve that's on the left. Okay, so I'm going to make that observation by filling in these x values. We now know, let's give ourselves a little more space here, that this curve on the left must be y cubed minus y. Okay, and that means that the one on the right must be 1 minus y to the fourth. Okay, so we have everything that we need to set up an integral to get our area here. Okay, so to get the area of this rectangle, we will start with the width of it. Okay, how would we measure that horizontal distance? Well, we basically just need to subtract these two coordinates. So we're going to take 1 minus y to the fourth minus y cubed minus y. And then we need to multiply it by its height. And the height is just this very small vertical distance. We'll call it dy. And then think of integration as the process of just adding up those rectangles from top to bottom to get the exact area. Okay, and what we're missing are limits of integration here. Where do we start integrating and where do we stop integrating? Okay, notice that in this problem, the variable of integration is y, and so the limits of integration should be y values here. Okay, so as you look at your region, where do we start adding up rectangles and where do we stop? What's the lowest y value in our picture and what's the highest y value? Okay, well, you can see from the picture, minus 1 and 1 kind of mark the top and the bottom of our region. Okay, so those should be our limits of integration. Okay, and we are ready to do this integral, so let's see what we get here. First, we'll simplify a little bit. Okay, and then if we take antiderivatives, we're going to get y minus y to the fifth over 5 minus y to the fourth over 4 plus y squared over 2. Okay, then plug in our limits. So let's see, upper limit is going to be 1 minus a fifth minus a fourth plus a half. Okay, and then subtract the lower limit. When you plug in the minus 1s, we need to be a little careful with the signs. So let's see, y is negative 1. And then if you take negative 1 to the fifth power, it's still going to be negative. Okay, and then let's see, negative 1 to the fourth is positive. And same for y squared over 2. If you square minus 1, you're going to get 1. So that's going to be a positive 1/2. Okay, and from here, it's a matter of just doing the arithmetic. I'm going to not go through that part of it, and just note that if you do that, you will come down to an answer of 8/5, which is our area.